Video number 19, example 8. I read the question. Express 10 Newton 60 degree in the form xi plus yj. Now this is a past SSA question. Here we are given a force in polar coordinate form. Polar coordinate in the sense that we are given the magnitude of the force, the direction of that force, and we're expected to convert this polar coordinate form of a force into the vector form. Xi plus yj is a vector quantity. So that is what we're expected to do. So what we do is to withdraw the four cardinal points. Draw the four cardinal points. Draw the four cardinal points. Draw the four cardinal points to social x and y axis, showing both the positive and the negative direction of both axes. That is the x axis. This is the y axis. And this positive direction of the y axis is always the north. The negative direction is south. This is west. And this is east. Now, the first thing we have to do is to locate this very first 10 Newton. As usual, the direction of all vector quantity are measured from the north, clockwise. So we measure 60 degree from the north, clockwise. That is 60 degree. So we draw the direction of the line of action, of the force. We draw it from the origin. Draw it from the origin. So this is 60 degree measured from the north. Now in this first quadrant, if this angle is 60 degree, then the remaining angle is 30 degree because they are complementary. That angle in the first quadrant is 90 degrees. So if part of it is 60 degree, automatically the remainder will be 30 degree because they are complementary. So this is the line of action of that force, which is 10 Newton. 10 Newton. Now I'm to convert this force to vector quantity. So all I have to do is to drop a perpendicular from the head of that very vector force. Drop the perpendicular from the head of that force vertically downward to the x-axis. Then this will be y. That will be at an angle of 90 degrees. So the whole shape has been transformed into a right angle triangle. Now, along the positive direction of the x-axis here is xi, because I is the unit vector along the x-axis. Then yj, that will be the vector along the y-axis, which is yj. So j is the unit vector along the y-axis. Now the task before me now is to find the value of xi, find the value of yj. So using the right angle triangle, using the trigonometrical ratio, or first of all, I can use the trigonometrical ratio to find the value of this x in the right angled, triangle. This xi is adjacent to this 30 degree angle. Then this force of 10 Newton is representing the hypotenuse of that triangle. And you know that adjacent over hypotenuse is cos. So xi over 10 is equals to cos 30 degrees, the cosine of the angle. If I cross multiply, I have xi is equals to 10 cos 30 degree. And cos 30 degree is 3 over 2. So this is 10 times 3 over 2. Cos 30 degree from your calculator is 3 over 2. 2 here, 1. 2 in 10, 5. So my xi now is 5 sod 3. Now, I am now to find the value of yj. So my xi is 5 sod 3. Also, this very yj is opposite to that angle. So opposite to our hypotenuse is sine. Yj over 10 is equals to sine 30 degree. By cross multiplication, I have yj is equals to 10 sine 30 degree. 10 sine 30 degree. And sine 30 degree is half. So that is 10 times half, which is 5. Now, the value of yj is found. Therefore, I'm now writing out my answers. Xi plus yj is equals to 5 sod 3i plus 5j. This is my answer. So I can write that 10 Newton 60 degree is equals to 5 sod 3i plus 5j. This is my answer. So I'm done.